Okay, so as Todd said, oh no, as in Myron, thanks for the brilliant introduction to the topic, actually. And well, maybe I address a little bit what you mentioned about policies, but we'll see. So Jupyter Notebooks as a front end for analysis facilities. I am Christoph Beyer from Germany, as Todd mentioned. I work for DESY, which is Deutsches Elektronensynchrotron. It's German and means German Electron Synchrotron, and it's located in the beautiful city of Hamburg, next to the River Elbe and the North Sea. And that's an aerial view of the campus. And so that's some numbers that might be interesting. We were founded in 1959. We have about 2,800 employees on site, including 1,100 researchers and roughly 3,000 visiting researchers from roughly 40 countries annually. The basic budget is around 232 millions, and we are 90% getting the money from the federal government and 10% from the city of Hamburg. We have two sites, one that you already saw on the previous picture in Hamburg, and then we have a smaller one in Brandenburg, which is Zeuthen, Brandenburg. It's next to Berlin, and it is the former Institute for High Energy Physics of the German Democratic Republic. And after the wall came down, we kind of united them to one organization. So these research areas we have mainly four cornerstones. We come deeply from particle physics. We were running a huge accelerator for a long time, and the predecessor of that, the predecessor is it was the predecessor for the LHC, if you can say. And we are still involved with particle physics. We do a lot of computing for the Large Hadron Collider in Geneva. And we also build accelerators, design accelerators. We are involved in astroparticle physics activities like the Cherenkov telescope array. And we are on site a huge photon science facility. So computing, we have two high throughput computing analysis facilities on site. The grid, which is mainly served by the usual job production factories from the big VOs like Atlas and CMS. And then we have a second analysis facility. We call it the NAF, the National Analysis Facility, which serves more the national high energy physics community with more interactive and individual workloads than the grid as such. Both farms are running HD Condor, and they have a central common store, Dcache, and the NAF has also a bit more storage, like home directories in AFS and GPFS storage. And everything in our society, in our VO, is pretty much data-driven. So on the right, the plot is about how much data we have in our main data storage called Dcache. And as you can see, up to 2020, it was mainly high energy physics. And then the photon science kicked in. And so today we are hosting roughly 180 petabytes on disk. And we have three analysis facilities running over this data, a high performance computing cluster, the grid, and the National Analysis Facility. And in sum, we run roughly 60,000 CPU cores and 380 GPUs. We run HD Condor and Slurm, and we have roughly 2,700 servers running to provide all this, compute storage, management, etc. And we consume around 0.8 megawatt. This is, and 1.3 megawatt is the total consumption of the data center, actually. So look at me, slide 10, I'm already at the subject. Jupyter Notebooks. Jupyter Notebooks actually run inside Jupyter Lab, which is not so much a buzzword, but it's at least for me, it's pretty much the same. So the Jupyter Lab as such is they call it a next generation web-based user interface for Project Jupyter. And it enables you to work with documents and activities such as Jupyter Notebooks. And the Jupyter Notebooks themselves are a very nice community standard for communication and performing interactive computing. Usually they are a mix of documents and code that blends in, and then you can compute it in situation and watch the output. We see that later in the live demo. And Jupyter Lab is the interface to create and interact with these Jupyter Notebooks. So why would you want a Jupyter Notebook as a front end for a high throughput computing analysis facility? Jupyter Notebooks as such are no batch tools. So they can run pretty much everywhere, on your laptop, in the cloud, on your desktop, virtually anywhere. And running them on an analysis facility is pretty interesting, though, from some perspectives. The server that is actually providing the notebooks, the JHub, is running the web interface, and as such can bridge the analysis facility access into the World Wide Web in a controlled and safe manner, which is mainly admin interest. And by doing so, the user might have access to bigger and different resources than he has locally available. So say you run it on your laptop, you will not have the same number of cores, RAM, or GPUs that you could access when you run the notebook on a Condor pool. But the even bigger things that you should keep in mind is that you will depend on a well predefined software stack running the notebook that is looked after, preferably by your VO admins that know what you are working on and provide software for you readily available, for example, in CVMFS. And then you have the wider environment of your notebook, like mount points, path variables, software versions. All this is then steady and defined by the admins that actually administer your environment on the analysis facility. Also, authentication and authorization is managed by the JHub, including all tickets, tokens, whatever you need to access the data and perform what you want to perform. Also, storage access can be tedious to be managed on your own, and by using a notebook on a pool, you will have hopefully all the storage access you need, and it's also faster. Well, hopefully most of the times. At least it's faster than at home in any case. Notebooks are very popular with traveling scientists, at least at DESY. We have scientists who have like a couple of days of beam time at the photon science facility, Petra 3, and most of them prepare the beam time in a notebook. Then they come on site, they do the measurement and data taking and tweaking of the experiment in the notebook. And when they go home, they just start the notebook at home, and it's pretty much as if they would come back to DESY physically, because they have all the environment, they have all the data, and all the work they made is readily available in the exactly the same manner than it was before. So they don't need to come up with a hard disk or download anything from anywhere. They just keep working on it. And also, Jupyter Notebooks are very popular with younger people in general. So Jupyter Notebooks in the NAF, we use the batch spawner to run them, which is pretty much the standard setup. So you would do it the same way with any kind of pool behind it. So we see the scientists here on the left hand running a web browser and using the web to access the Jupyter Hub, which is in the DESY data center. And he's then starting the notebook. So the Jupyter Hub is submitting a Condor job to the collector, negotiator, scheduler of the Condor pool. This is actually a dedicated one because we want a bit of a fast response and not clutter this interactive job in other jobs that the user might have, or maybe the quota of his group is just not allowing him to start the job, and then he would sit there and wait forever. So we try to allocate a resource to this job as soon as we can. Therefore, we have a dedicated collector, negotiator, and scheduler. So once this is negotiated, the scheduler will claim a slot in the pool on an execution point. The notebook starts, and the Jupyter Hub will then connect to the notebook. and give access to the user to the notebook. This traffic is going through the Jupyter Hub, so the firewall is bridged through the Jupyter Hub with this traffic. It's only the drawing is not very precisely here. So Oliver will have a talk in a minute, and he has some more nifty setups, I think, and he will show you how to do it properly. So Jupyter Notebooks, when we first started them and how we envisioned them and implemented them in the first place, it was, I think it was in 2018, at least going back in my emails, was the first time we mentioned them on email, and it was when IT infrastructure collaboration with Bell 2 was intensified. So what we thought is, oh, the Jupyter Hub is bridging the NAV into the wide area network, and small reserved slots for notebooks will be sufficient because it's more or less just the Conda submit wrapper, right? And we run it on a soft policy to not annoy these interactive users by stopping the notebook every now and then. And a fast start of notebooks would be desirable for them not to wait too long for starting to work. And then user will probably use HTMap and the Python bindings and outsource all the workload out of the notebook into the pool, like every good user does. And older VOs like Atlas and CMS will probably adapt to Jupyter Notebooks. And we start with the Bell community because there at the time already it was overly popular to run Jupyter Notebooks, and the others will probably adapt, and it will be a default means somehow of access to the pool. And as I said, Bell will heavily rely on them because they are widely accepted in their community. And we also did foresee already that debugging issues beyond the notebook start itself would be probably time consuming, and we need to provide some Python knowledge to be able to help people. So after 2 years of usage, well, reality strikes. Some points were right. Jupyter Hubs are brilliant in bridging the NAV into the wide area network. Point taken. But the small reserved slots for notebooks were totally insufficient on the NAV workers. So they were using a lot of memory and got periodically stopped all the time, and so they did not work in the way we supposed them to. The fast start of the notebooks worked out quite nicely. We were running them a bit under 10 seconds start time, and that's mainly not Conda who is eating the time. It's more the setup of the file system and everything. But it's absolutely okay. 10 seconds is absolutely okay. Nobody's complaining. And users were not using HTMap and Python bindings at all, never, at no time. In the beginning, it wasn't working because we had a bug, and nobody was even asking about it because the idea to outsource any workload into the Condor pool was just not there. And established VOs like Atlas and CMS, they adapted to Jupyter Notebooks, and now we have roughly 50 notebooks running during a normal day, and from all VOs. Bell actually heavily relies on notebooks. That was foreseeable. And debugging issues, yes, as I said, once you are in these Python dependency hells, then it gets really nifty. But actually, it's not as tedious as we thought it would be. So, summary and outlook. What we learned, users want to scroll through bigger amounts of data inside the notebook, and they are not in general prepared to outsource any kind of workload. It's only 2 weeks ago that first user showed interest in submitting from inside the notebook and thought it was kind of a interesting but crazy idea. And bigger notebooks in terms of memory only partly are a solution to this problem. It's a bit similar to fixing a memory leak. As an experiment, I removed the boundaries, and then they use like 100 gig easily because they just, or some of them just don't care about how much memory they consume actually. So now at the moment, since Wednesday actually, we provide 3 classes of notebooks. We have a standard notebook with 12 gigabytes of memory and 1 core, which is running 12 hours. And then we have a medium-sized notebook, which has 20 gigabytes of memory and runs for 6 hours. And we have a big one, which is 48 gigabytes of memory and 2 cores, and it runs for 3 hours. Actually, I cannot tell you much about how this concept works out because we just ran it since Wednesday, and well, we'll see. We have a drop-down chooser in the JHub, so you can choose your notebook. And the bigger notebooks now run on 2 dedicated servers, and the regular ones, so the 12 gigabyte, 12-hour ones, they run in smaller reserved slots on all the workers. We will see how this works. If nothing else, it will probably raise the awareness that there are limits because you can choose limits. And at the same time, we try to introduce Jupyter Resource Usage, which provides a nice memory reminder in the upper right corner of the notebook. And we tried Dusk and Spark as memory schedulers in conjunction with Jupyter Notebooks. It's tested and works, but it needs some tweaking and also setup knowledge by the users. So it doesn't, at the moment, it's not an out-of-the-box solution to gather more memory than we actually provide. So while I have your attention, some things, of course, would be nice to have. Both HT and Jupyter Notebooks run pretty much as if they were industry standards, maybe because they are. And administering both of them together, playing together, is much less of a hassle than we anticipated in the first place. But we have a big lack of any communication back channel from HTC to the notebook. So the JHub as such is not aware in any way that the notebook is running on a high throughput remote system. So it would be nice to give the user a hint, to send a pop-up, for example, in case of limited runtime or in case of the memory usage nearing the limit. And also maybe small statistics could be blended in about the performance of the node we are actually running on. Like if IO weight on this node is very high, then it would be nice to just say to the user, hey, we're kind of busy and we're working on it, but this takes a bit longer than we thought. And then the user can decide if he just shuts the notebook down and restarts it somewhere else. And in general, it would be nice to make the notebook more aware that it is running on a remote resource with some possible boundaries. At the moment, this is just not possible. So I think that's it. I'm on my last slide.